Okay, so we're talking about the first 5 terms of the geometric sequence. All right, the first term's 10, because it says so right here. And so if I was going to just predict for me, you have to use a calculator here. What's the next term going to be? 20, because it's got this 2 here. So it's 10, then 20, and then what? 40, and then what? 80, and then what? 160. All right. Which are the first 5 terms? These are the first 5. That is the first term. Even though it's u sub 0, it's the first term. Now, this is not numbered in a way that would give us the 5th term very easily because it's using a 0 here. So it's a good real-world kind of problem where we would say, like, after 2 years, that would be right here is u sub 2, and yet it's the 3rd term. So again, you got to be careful with those. The way it started with was with u sub 0 this time. All right, so let's say that we wanted to graph this thing. Do you get that the graph of this right here is geometric because it's curving? All right, if it had been straight, what's that called? Linear, which is unknown as what kind of a sequence? Arithmetic sequence. Good. So this is a geometric sequence. If it had been a straight line like this, then it would have been an arithmetic sequence. All right, next slide. How can we rewrite the first 5 terms as multiplication involving just 10s and 2s? All right, so here's what I'm trying to say. 10, 20, 40, 80, 160. How can I make a 10 out of a 10 and a 2? Well, 10 times 2. But 10 times 2 is 20. 10 times 2 to the power of what? 0. Because did you get the 2 to the 0 power is equal to 1? And then 10 times 1 is 10. So it worked. How can I write this with just 10s and 2s? So here's another 10 and here's another 2. 10 times 2 is 20. Except I could put a little power on it still. A 1. So then the next one will be 10 times 2 to the second, because 2 to the second is 4. 4 times 10 is 40. See what's going on here? All right. So then, unless you're kind of slow on the uptake, you're figuring out that each time after this, I'm just going to be changing that power to 2 to the something else. All right. So then if I said, instead of this, I said u sub n, it would still be 10 times 2 to the n. Very good. All right, so now what did we do? We just rewrote that as a function like this. Y equals 10 times 2 to the, and they want this as a function of x, to the x. I talked this through with you back about a week ago or 2 weeks ago. I reminded you how this could be done. We took a recursive, like this, and now we're writing them as exponentials. The way you do it in pre-calc, it's like this. This way is good to know because it can be on SAT, ACT tests, and also on the MCA test, the big one that the state gives you. You have to know that recursive notation. Now you know it, and it's not that hard once you've seen it. All right, one more thing. Do you remember when we had these and then we'd have like 1 plus 0.5? Why did I write that instead of 1.5? Because you know it's growing by 50%. It has the growth rate right here. What if this had been a minus? Then it wouldn't be a growth rate, it would be a decay rate. All right. Next slide, everybody get to this one. All right. What is the y-intercept of this graph? Well, I see the graph, and so I just have to go, oh, there's a y-intercept. It's wherever it touches. But what if you didn't have the graph? What if this graph didn't exist? How could you get the y-intercept? Define it for me. The y-intercept is where x equals 0. You got to keep that in your head. I'm telling you, even in pre-calc, it comes up over and over and over again. The y-intercept is where x is 0, and the x-intercept is where y is 0. So if I want the y-intercept, I just put a 0 there. Do you get how 2 to the 0 would be 1? And 1 times 10 is 10? And you might say, well, for me, I'm just going to always look at the graph. Well, we're not always going to give you the graph. Sometimes you're going to have an equation like this. Y equals 5, 1.3 to to the x plus 7. And we'll say, what's the y-intercept? And some of you will say, oh, the y-intercept is 5. And you'd be wrong. Are you on the same slide as me?
Yeah.
Okay. All right. The x-intercept is where y is 0, and where's the y-intercept? Where x is 0, so I'd put a 0 here. Do you get how this part turns into 1? And 1 times 5 is, and then 5 plus, okay, what are you talking about? I'm just curious. I'm going to pause for a second and find out. All right. So back to, the y-intercept is where x is 0. So I stick in a 0, this turns into, whoa, what happened there? This turns into 1, that whole thing. And so it is recording. Thank you. See, look at the number changing. Okay. And that's a 1. 5 times 1 is 5. 5 plus 7 is 12. Y equals 12. All right. So let's move on. List the first 5 terms in this sequence. This one, you're going to want to use a calculator. Grab your graphing calculator. Type this puppy in. I'm going to hit pause while you do that. All right, so if you type that thing in, you should know that 16 goes down. Think about it for a second. Look at this. Does it go down 75%? No. It goes down 25%. Because I could have written this as a 1 minus 0.25. That's the same thing as 0.75, right? And that would make it clearer that it's going down 25%. And if it's 16 and it goes down 25%, I think it's 12, right? And if I go down 25% off of that, I would take off 3, which would make it a 9. And now 25% off of a 9 doesn't work so nice. It's not clean anymore. What was it, though? Remember the extra? 6 point. Thank you. And then that going down 25% goes down to, what, 5 point something? What? 5 point what? 5.065 or something like that? Thank you. Okay, so there's my first 5 terms. Now, could I have written this as an explicit equation? Absolutely, and let me show you how. I would have said y equals, and I bet you can tell me. Remember that other one we made it up of 10s and 2s, and the 2 was the thing that was making a double, right? So this, what does this start with? So I put a 16 here. And then this could be a 0.75, or I like to write it as 1 minus 0.25. And then what else does it need? An x. Where should the x be? In the exponent. Because if you have an x in the exponent, then it's exponential. Something you're going to deal a lot with more next year in pre-calc. But if there's an x in the exponent, then you have an exponential. All right, so now that equation would also create a table, just like what you're doing with your recursive stuff. So now what we have to do is go back into your calculator, show you how to do this without recursive. If you just want to do it like this, because this is a lot less complicated than recursive, because you just type it into the y equals screen. But you don't have a y equals screen anymore, do you? Because you're in sequence mode. So go to mode on your calculator. Once you've pressed mode button, then the 4th thing down, you change it out of sequence mode and turn it into func mode. And it's not for funky, it's for function. Okay, get your calculator in function mode, not sequence mode. Then go back into the y equals screen and type this into your equation in the calculator. And I'm going to suggest that instead of just putting an x like this, I should go like this. Caret x. Because that'll remind you it's to the power of x. Did it work? Yes. Good. If it doesn't work, common mistakes I see people make, sometimes they make that the negative sign instead of the minus sign. You want a minus sign in there. And yeah, it is a lot easier. And other common mistakes, if you can't get the table to come up, sometimes it's because you have a plot on your calculator. And it's above the y equals things. There's plot 1, plot 2, and plot 3. If one of those is darkened in, then it won't play nice. Okay, so if yours is working, then you should be able to just go to the table And do you see the same numbers there? Look on your table and see if you don't see the 16, the 12, the 9, the 6.75. Would you please get it on that table so I can see that you have it done right? Table.
Table.
Okay, there you go. Good. Good, good. Just doing a quick scan to make sure everybody's on track. Good. 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 Good, good.
What do they use to record the stuff?
Khan Academy, I think, just uses the thing that's built into Windows. It's like Paint. You know what I'm talking about?
Really good handwriting. So
He may have a new thing now, because now he's sponsored by Bill Gates, and so he probably bought himself a nice thing to record with. Because seriously, I think he got funding from Bill Gates, like millions of bucks. What? That's okay. All right. So now, this kind is a recursive. Remember? What's the kind we just made called? Yes, they're either linear, which are arithmetic, or they are geometric, which are nonlinear. They're curved. But Sunny, this one is which kind? Is it curved or not?
Yes.
It curves, so therefore geometric is correct. Okay, good. All right, so if I were to look at these two formulas, what's that one called? Look up here, please. What's this one called? Recursive. What's this one called? Exponential. All right, good. Is it a 25% decay rate? Nope. It's actually a what percent decay rate? 75% decay rate. Good. And its initial value, or its starting value, or its y-intercept is 7. If there had been something out here, it would have moved the whole graph up 5. Do you get that? Same as all the other functions we did. If you put a plus 5 out there, it moves the whole thing up 5. What if I wanted to move the whole thing to the left? 5. Yes, you'd put it inside with the x. And this would be like a plus 5 right there. That would move the whole thing left 5. All right, so some of your questions that you have are real-world questions like this. And I do not need us to do any more recursive, so we're not doing this part. But let's try to figure out how this would look as an explicit formula. So you start with y equals. Everybody get to this slide, please, and write y equals. And then see if you can write the formula yourself without me. And I'll tell you in like 30 seconds what it would be in case you don't get how to write these. You want one of those formulas that has a little x in the exponent.
Does that mean like
It is decreasing by 18%. Depreciate means decrease, yep. Go down in value. So if I were writing it, I'd put the starting value here. I think most of you did that. What goes in there? Got 2 people answering, but okay, you're right. It's 0.82. Could you have written that as a 1 plus or a 1 minus something? 1 minus what? 0.18. Okay. And then one last thing. Yes. X in the exponent makes it exponential. Okay. Now, I'm going to ask you not to go back and do it recursive way. We're just going to do it this way. Type this one into your y equals screen. And then here's the one trick on this one. It asks you to find the car's worth after 3.5 years. Well, we'll know what it is after 3 years and after 4 years on the chart. But then I need somebody smart to figure out, and don't just tell me average the two. That's a good guess, but yes? Go to table settings. You're right. Change value. Yes, there's a little triangle in there. You want the triangle to not change by 1s anymore. What do you put it at? 0.5s. Everybody, please do that. So type this into your y equals screen. Once you're done with that, go to table settings and change it so it doesn't count by ones. Change it so it counts by halves. Yes, sir.
Can you do the use of 3.5 or is that only
Recursive, you're talking recursive language now, so don't do that. That was what we would have done last chapter. All right, so now, if you go to your table and you look up 3.5, notice this is after 3.5 years. That does not mean the 3.5th term, but we just have to find 3.5 on the table because we're setting it up right for a real world problem. All right, so what does it say, by the way? What did you get in the table for this? 3.5 is what? 8987? All right, now, just think for a minute. That is a car that's gone down 20% each year. That's gone down pretty fast. It was 18 grand, now it's down to only worth 9 grand. That's like half of its value. Yeah, that's what happens. If for 3 years you lose 20% of your value, 3 years in a row, boom, 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 that's going to hurt. It's going to go down a lot. All right, so let's move on. Everybody, go to your y equals screen. Type these 4 equations in order. First one's got to be 1 to the x. And when you hit graph, watch which one goes first, because that's the 1 to the x. And then each one that gets bigger, the bigger the base gets, see what the graph does. Here's what happens. This one is your, if you type in 1 to the x, that's the one that just goes straight across. Why is that? Because 1 to the first power, 1 to the second power, 1 to the third power, 1 to the fourth power, they're all the same thing. What is 1 to the fourth power? 1. Get the idea? That one's a straight line. But each one after that, it gets to be more like the normal kind. Y equals 2 to the x, that's this curve. Y equals 3 to the x gets a little bit steeper. 4 to the x, steeper yet. And I'm going to use the blue one for the steepest one. 4 to the x. Do you get that it just goes up steeper and steeper each time? So the bigger the base is, the tighter that it is to the axis. So if you had to assume you had graph y equals 50 to the x, can you imagine what it would kind of do? It would be super, super tight to the axis. It would be like straight up pretty much. Okay, notice that they all go through that spot. Why do they all go through that spot? That's because that's where you're putting in what? You're getting an answer of 1, but what are you putting in to get that answer? 0. If you put in a 0 here, you get a 1. If you put in a 0 here, you get a 1. If you put in a 0 there, you get a 1. Get it? Because if 4 to the 0 power is 1. 2 to the 0 power is 1. 1 to the 0 power. Anything to the 0 power is going to be 1. That's why it always goes through there. Now, can I make this graph get off of that spot? Yes. But the only way is to say y equals, say, 2 to the x. Let's say I wanted to move up a spot, so it's not going through 1 anymore. Plus 1 like this. That makes it move up 1. Then the whole graph that used to be like this, whoa, jumping marker, that used to be like this would move to be exactly up 1. Everything's up 1 higher than it used to be, kind of thing. All right. So now, we're not going to go to that QR. It just for future reference. It is it's a lesson, like written out of what I just taught you. So if I had to like write out the whole lesson, it would look like that. It's kind of cool, but you don't need a written out lesson because I'm teaching it to you verbally. So, all right, these guys right here, I just want to tell you what they do. They are not growth, they are decay. If I'm going to go through this spot, which is at 1, and I go down like this, which one is decaying more? The red one or the black one? Black is decaying more. And so its equation, just think about it. If I was going to make an equation for this one is decaying what percent? The black one's decaying at what percent? 20% decay. So the red one is not decaying as fast. So the red one would have to be something like 0.9x, because the red one is only decaying at what percent? 10%. Okay? So bottom line is that the more it decays, like let's do a crazy one. Let's do the screen one. Y equals 0.5x. That's 50% decay, and if it had 50% decay, it's going to go down way steeper. Get the idea? All right. So think about the decay rate, and you'll be able to know, oh, well, that's a 50% decay. That's going to be decaying way faster than that one, and so it's steeper in the down direction. All right, last thing is, if you were looking at this black graph right here, I'm pretty sure this is not in your notes, so just look up here, please. See this? There's a black and a red one. The black one's like the parent one, and it says in the directions that it is 2 to the x, shown in black. Y equals 2 to the x. If I want to change it to the red one, do you get how I have to move this thing to the right? Do you see how it's 1, 2, 3 spots over to the right? Same with this dot, 1, 2, 3 spots over to the right. So if I want to move this 3 to the right, what's the right answer for the equation? Do I do plus 3 like this? No, minus 3 would move it down 3. I put it by the x, and up here in the x area, if I want to go to the right 3, I'd go minus 3. Okay. All right, so this one. The black one's the parent one. Do you see that the red one's been moved up? How much higher is it? 2. Now it's important. Did that just double, or did it move up 2? Well, here's how you can tell. This one was a 1, and now it's a 4. No, it's a 3, sorry. It was a 1, and now it's a 3. Do you get the difference between these 2 points? Do you see how that is either tripled, because 3 times 1 would be 3, or it's added 2? And you can't tell until you check the other point. This point is also just moved up exactly 2. So obviously it's not being tripled, like that first one could have been being a triple. So I can tell, since they're both up to, that I should take the equation 2 to the x, and to move it up 2, I go like this, plus 2. All right, let's look at one more. These guys. How on earth, let's look at these two. How on earth do you get that to happen? Negative. All right, so if the parent one is, see this parent one? It's not 2 to the x anymore. It's 1/2 to the x. It's decay. Okay, because see the black one's going down. That's decay. So it's y equals 0.5 to the x, and then do I want to make this thing flip up, down, or left, right? All right, left, right would definitely not do it. It's up, down, flip. All right, and now if this thing flips up, down, is that on the outside or is that on the inside?
Negative outside.
Negative on the outside, okay. Now if I just simply flip it up, down, is that all I needed to do? Can you see that that black one, if I flipped it up, down, would actually go like this? Up, down, flip, and then a move. Which way? Up. You get how I have to move this thing up now? How many spots up? Well, you can see where it crosses. That's up 1. That's up 2. I'm looking at the y-intercept now. That's up 3. That's up 4. That's up 5. So it's not only an up-down flip, it's also moved up 5. That's where this stuff gets to be hard enough to actually make it a challenge for you. That's probably one of the hardest ones on your homework, and I just gave it to you. So, and it's actually the same problem. So if you're taking notes or paying good attention, you're fine. All right, that's all we have for you for today.